It's Mr. Rops here. In today's topic, we are going to talk about investing money using our calculator and how to go about do it when we do monthly payments into an investment. So if we take a moment, read the problem, we'll read it together. Maddie at the age of 20 got a job that pays $48,000 per year, and she's paid monthly. She takes 10% of her monthly salary and invests it into this particular retirement fund. And she's very smart. This is very good life planning, to take 10% of your salary and invest it forever and never touch it till you retire. She has the same job until she's 62 and retires. So this particular fund has averaged since inception 7.63% per year, and we're going to assume it's compounded monthly. So over the years, how much money did Maddie invest? Well, we know that she 62 to 20 years, so I know that if I go 62 minus 20 is 42 years of investing. So she invested for 42 years, and she's putting in $400 a month, which I took 48,000 divide that by 12, which is the months. And then I want to multiply it by 10%, which is my 400. This is 400 per month. And she does it for 42 years. There's 12 months in a year, so she's going to go 42 times 12 months times 400. So in total, Maddie has put in 201,600. Okay, so this is how much money she's invested in total. This is A part. So 20600. So just over $200,000. So in class, I would have done this value, get people a sense of how much money she would have if she invests this money. So now we're going to calculate the value of the investment. We're going to do it two ways. One, we're going to do it by pure algebra, and the second way, we're going to use our TMB solver. Okay, so if we're going to do it by algebra, I want to think about what's happening. So, okay, this is quite involved. I know that I am going to take 400 in that first month, and then I put that in at the beginning of the month, and then it collects interest, and the interest is going to be 1 plus 0.0763 divided by 12. This value here, well, let's see how much this value here is. I'm going to move it over here. I know that that is going to be 1 plus 0.0763 divide 12. And it's this big giant long decimal, so I'm going to store that, because I'm not going to write that decimal, into alpha R, which is QR, multiplication sign, R for A. So I'm going to call this is equal to R. And so I know I'm going to take my $400 multiplied by R, okay? And then what happens is at the end of that month, I add another $400, okay? And then all that money gets multiplied by R. So now I have 400R squared plus 400R. And that's at the end of month 2. So then, the beginning of month 3, I add another 400. And all of that money gets multiplied by R, and so on. So now I have at the end of month 3, so at the end of month 3, I have 400R cubed plus 400R squared plus 400R. Okay, and that goes on for all the months that I do it, and so on and so forth. Okay, so if I want to find out how many months in total, I know that it's going to be 42 years times 12 months. So she's doing this for 504 months. So this is at the end of the third month. I have this much money. So if I continue the pattern, in the 504th month, it's going to be 400r to the 504 plus 400r to the 503 plus all the way down to 400r. 400r. And this is all the 504 months that she's done it. Now I need to add all this money up. So, and remember, r was this value here, which was 1.00635 and so on. And so in order to do this, well, let's make life easier on ourselves. Let's factor out a 400r. And so I have r 503 plus r 502 plus all the way down to plus 1. And so I want to find the total. Well, let's consider what this here is. In order to, this will be r here. In order to go from 1 to r, I multiply times r. This here, I can multiply times r. And that'll be r squared times r, and so on. And so this is a geometric series. And I think about this as my first term, u1, and this is u2, all the way up to u 504, because it's the squared is 1 less. So then, if I'm going to calculate that, so I have my 400r, the sum of all these terms is going to be u1, which is 1, times r to the n, which is 504 minus 1, over r minus 1. And so now I'm going to put this into my calculator. And so I get 400, I'll just use r, times the r to the 504 minus 1 divide by r minus 1, and I hit enter, and Maddie will have 1, 4, 8, 1, 2, 4, 5, 6. She will have $1.4 million in her investment. If she puts $400 away a month for a year, she only invests $200,000, and she's got over 1.4 million in interest, a total of in her investment. That is a lot of interest. So we can also do this with our calculator. Well, I'm going to use a TMV, but let's go through these values here. N, I know, is my months, so it's 504. My interest is 7.63. My present value, when it starts off, it is 0. The payment is going to be minus 400 because it's leaving my pocket and going somewhere else. The future value is what we are going to be looking for. My payments per year is 12. My compounds per year is 12. And I put the payment in at the beginning of the month, and then I get interest. Okay, so if I go to my apps and my finance app, my solver, I'm going to go 504, 7.63. My present value is 0. My payments are negative 400 because it's leaving my pocket. That I'm going to find. This is 12 and 12, and I'm going to put it towards the beginning of the month. And if I go back, now if I go alpha, solve, I get the amount of money that Maddie is going to be saving. And so using our calculator is quite handy. It makes a long algebra problem go by pretty quickly.